Hello and welcome to Lecture 4 of the Work Unit in Phys 1104. We spent the last lecture looking at work done by constant forces. Now we need to look at variable forces. Let's think about two objects, an agent and a target. And there's some interaction between them. And it doesn't matter what kind of interaction this is. Perhaps these are two carts, and this is a magnetic interaction between them, or maybe they're two objects connected by a spring, but there's some interaction which results in the agent exerting a force on the target. And the important thing for our purposes is that that force has to be a function of the position of the target. Now remember that for a one-dimensional case, the work by a constant force is just the x component of the force times the x component of the force displacement vector. And if it's a constant force, then if we graph the force versus the position of the object, it's going to be a horizontal line. And now we can interpret this expression for the work as an area of a rectangle, because this height is just the force, and this width is just the force displacement. And so this expression is talking about the area of this rectangle underneath the function. Well, hopefully you know what's coming, because I've made this same argument several times in this course. Let's now think of a variable force that depends on the position in some way, and it's no longer a horizontal line on the graph. Well, I can draw rectangles under it to get an approximation of the area under it. And so, for example, I could choose a rectangle which is centered at a position that I'll call xn. And so the height of that rectangle would be what we would call f of xn. And now if each of these rectangles has a width that I'll call delta x, then I could say that the area of this rectangle that I've selected here, which I could call the nth work, is simply that force times that width. And now the total work is approximately just the sum of all of the works calculated by adding up the areas of these rectangles. Well, the final thing to do is to think of making the rectangles narrower. And as we make them narrower, we expect that they become a much better approximation to the actual work, the actual area under this graph. And so we will approach the point where it is in fact equal to the work we're looking for if we have taken the limit as the width of the rectangles goes to 0 of this sum. And that is what we define as the integral from whatever x initial to x final we're talking about here. The integral of this force function with respect to x. And I still know that you do not know how to evaluate these integrals. I just want you to remember that this is more or less just a short form for the area under the graph, however you get it. And you can get it formally using calculus once you know how, but sometimes you can approximate it or even get it exactly without knowing any calculus. So we've seen that work can be calculated from an area under a force versus position graph. But when is that valid? Our starting assumption was that the force had to be position dependent only. That turns out to be valid for non-dissipative forces, and we can argue it from reversibility. If we reverse the velocities, that's just like reversing time, and by reversibility the forces shouldn't change, so the forces must not be velocity dependent. But now let's think about something like friction. Now, it's a common misconception that the strength of the friction force depends on speed. In fact, it doesn't. However, think about a block sliding to the right across the floor. The friction on it is to the left. But if you reverse it so the block is going left, now the force on it due to friction is to the right. And so the direction of friction does depend on velocity. Friction, therefore, is a velocity-dependent force. It's not a function of position alone, and so we can't get it from an area under a force versus position graph. And the same goes for something like drag, which is explicitly dependent on speed. Calculating work due to a variable force is going to be something we're going to have to do a lot of as we go on, and especially in Phys 1204, so let's check that you understand how to do it. So here's a very simple variable force graphed, and I tell you that an object goes from x equals 1 meter to x equals 3 meters, and we want to know how much work is done on the object as it does that.